All right, so I wanted to keep a couple of monosaccharides on there. Here we have alpha D-glucose. Here we have beta D-glucose. So, and here we have beta D-fructose. These are all examples of what we call monosaccharides. So it turns out sugars can also form polymers. So like a lot of, like your amino acids can form a polymer, which we call a peptide or even a protein. So sugars can also form polymers. So, and the monosaccharides are the monomers in those polymers. So these are monosaccharides. Fructose, glucose, there's a lot of them, right? Galactose, ribose, ribulose, xylulose. There's a boatload, more than I can name in a short period of time. I would know glucose's structure for sure. If any others she mentioned might be good to know those. But obviously, we can't expect you to know every single sugar's structure. But definitely know D-glucose and D-fructose. Know how to make them alpha and beta. So, all right, so in this case, you got some common disaccharides as well. What do you suppose a disaccharide is? Yeah, you have two of them hooked together, two sugars hooked together. So in this case, let's look at a couple of disaccharides. So, and I first want to look at the one you're most likely to eat, sucrose. Sucrose is a disaccharide. So you eat this all the time, right? So and if you look, I got it on your handout there. So, but sucrose is a glucose hooked up to a fructose with an alpha beta 1,2 linkage, we say. So now we're talking about how sugars connect to each other. This is kind of the designations we use to talk about how they connect. Now what this means is that the glucose, the first one named, is hooked to the other sugar through carbon 1. The fructose is hooked to glucose through fructose's carbon 2. Now notice for glucose, so carbon number 1 is at the anomeric carbon. Is carbon number 1 anomeric for glucose? Yeah. And if it's anomeric, then it could be either alpha or beta, which is why I had to tell you that it was alpha. So for fructose, is carbon number 2 the anomeric carbon? Yes, which is why we also had to tell you that it was alpha or beta. Notice if you hook up through the alcohol of any other carbon besides the anomeric, you don't say alpha or beta. It just is what it is. But if it's the anomeric, you better tell me if it's alpha, beta. That's what the designations refer to. Notice if I would have just said alpha 1, 2, then it would have implied that whichever one was the anomeric in this case would have been the alpha. And so usually they kind of go alpha 1, 2 or 1, 2 alpha sometimes just to kind of specify. But either way, whoever's anomeric is the one getting the designation here. So let's look at this here. So if we want to make glucose fructose with an alpha beta 1, 2 linkage, I need to hook up alpha glucose with beta fructose. And I need to hook them up through the OHs on those respective carbons. Water is lost in the process, and we're just going to form, a carbon-oxygen-carbon bond in this case. So we'll start this from scratch. If this guy needs to point down because he's alpha, and this guy needs to point up, he's beta, then I'm going to probably draw this one on the bottom and this one on the top of it and connect them, if you will. All right, so in this case, I wanted alpha on the glucose, you're right. Let's go back a sec. So the glucose needs to point down, the fructose needs to point up. So I need to draw the glucose higher than I draw. I even had the monomers listed out. This is kind of pathetic. I'm just going to let you know that. So this would have been a beta alpha 1, 2. So this guy here. So again, glucose is my alpha, fructose is my beta, and then calling it glucose fructose alpha beta 1, 2. That's what I actually really, 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 really this time wanted.
So when you have drawn on the left, the beta alpha 1, 2, is that sucrose or is that something else?
This is sucrose.
Okay.
It's glucose, fructose, alpha, beta, 1, 2 linkage. And so alpha, beta, 1, 2, the 1 goes with carbon number 1 of glucose, and the 2 goes with carbon number 2 of fructose.
Right, so the one on the left is different. Is that,
Correct.
Is
this
that
is
sucrose or is that called something?
It's, in this case, this is not called sucrose. It's something else. I don't know what it is. Don't know if it's a common living organism disaccharide, but this is sucrose. So by saying sucrose, it's a very specific 2 sugars and what linkage they have. That linkage determines what the disaccharide is as well, just as important as what the sugars are themselves.
Okay, thanks.
Well, so let's talk about some polysaccharides. So a disaccharide is an example of an oligosaccharide, so which would be just a few monosaccharides stuck together, but you get polysaccharides. Polysaccharides come in a variety of forms. So if you look, I listed a few of them there. Amylose is a linear glucose polymer. Where do you find amylose? So that's amylase, but where do you find amylose? Starch. Starch. Notice when you hear ACE, yeah, ACE is the enzyme, OS is the sugar. So amylase breaks down amylose. And so amylase is typically designed to break down alpha 1,4 linkages between glucose monomers. That's what amylose has. It's a bunch of glucoses, just all glucoses, hooked together with a very specific linkage. Notice, look at amylopectin. What's the difference between amylose and amylopectin? Amylopectin is still all glucose, but how are the glucoses connected? So you still have a bunch of alpha 1,4 linkages forming big long chains, linear chains. But then you also have some additional branches with alpha 1,6 linkages, so it gets cross-linked a little bit in various places. That's the only difference. So you also got glycogen. Where do you find glycogen? Where at? Muscles and? Liver. So it's in your muscles and your liver. Why is it in your muscles? Because your muscles might need energy. And they don't give it away. They say, this is for me, it's reserved for me, I'm not giving it away. But the liver, what's your liver holding on to glycogen for? So, yeah, and in this case, it's just releasing sugar into the bloodstream. If your blood sugar goes low, then your glycogen gets chopped up, releasing the individual glucose monomers, monosaccharides, into the bloodstream. That's what it's for. Notice, when you go on the Atkins diet, what do? What do you cut out of your diet? Carbs. Problem is your brain loves glucose. You cut out the carbs, you cut out the glucose. All you got is protein and fat. And your liver says, oh crap. And your liver uses up all of its glycogen. Well, glycogen loves water. It's like a sponge, a molecular sponge. And so as soon as you burn up all your glucose, then you have all this excess water that your liver says get rid of it. And so guess what a lot of your initial weight loss is, typically? Water weight. Which is why people are like, I lost 10 pounds in the first week. Well, we'll see how it goes in the second week, you know? You've lost all your water weight. You've lost your glycogen stores. I'm not saying it's a bad diet or a bad idea. You got to cut some carbs to lose weight. I'm just saying your results initially are better than they really are. Because guess what happens the first time you start eating carbs again? Oh, let's replenish our glycogen back in the liver. So, glycogen is also just pure glucose. Polymer, big glucose polymer. It's very similar to amylopectin. So just a lot more alpha 1,6 branches. Very highly branched structure, at least, well, I shouldn't say highly branched, but a lot more branches than amylopectin.